Hi, everyone. Good afternoon. My name is Daniel, and we'll be talking about the Gemini 3 playbook for optimizing for speed, quality, and cost. My name is Daniel. I am a product manager on the Google side, working on the Gemini model quality and lifecycle. And I'll be joined today by Darvish from Salesforce and Skander from our applied AI engineering team, and we'll be talking about the problems, I think, and the experience of working with LLMs today. It feels like there's lots of trade-offs that customers have to make when using LLMs, how we at Google think about it, and how we want to be able to provide like a two-way support system such that it doesn't feel, it's not like a lonely process, that building with AI, building with our models is not like a one-way lonely process, but a two-way thing. How we've found success using this playbook with Salesforce, and then some more tactical techniques and tricks with Skander, and then finally I'll wrap it up. Okay, so I'm gonna talk maybe about the optimization triangle. So when building with AI and LLMs today, it kind of feels like you have to pick between these three things: quality, cost, and speed. And whenever you maybe are able to optimize for two things, but you're not able to really optimize for three. And this is a big decision, or a big kind of trade-off that we are monitoring at Google, and how we think about launching new models, what we care about, making sure each model is really good at. And I think the main thing that I want to call out here is, at Google, we want it to feel like you're building with us, as opposed to just this black box. You come to Google, you ping our API, and that's the end of the story. We want it to feel like a two-way street where you can give us feedback, tell us what's wrong, what's not working, and we're working to kind of address it either today or tomorrow. And that kind of brings me to my next point about we want these models to work for you. Gemini and all of our products are built for our customers, and if it's not working for you, then it's not really a great product. And I've kind of framed it in two ways of how we're supporting customers. So one, how we're supporting customers today and helping you pick the right model, but also launching a variety of models across our portfolio to optimize for those three things. And then two is when you pick a Gemini model, how we can support you in tweaking that model such that you're able to optimize it and get it to the place where you want it to be. And then in terms of tomorrow, I think this is a new thing that we want to get towards, is we found that or as we've all noticed, performing really well on academic benchmarks or these leaderboards doesn't necessarily translate to how it's going to perform in the real world, especially for more complex or agentic use cases. And we'd love to build a partnership such that you're helping us shape what the roadmap for Gemini should look like, as well as we're giving you insights into what our roadmap looks like such that you can shape yours. Cool. So with that, today we are launching a large kind of gamut of models, and I've kind of tried to map it onto this triangle of Pro, Flash, Flashlight, and Gemma 4, and how we're thinking about that quality, cost, and speed trade-off. I think maybe the main thing to take away from here is making sure that you're picking the model for the best model for the job. You don't necessarily need a pro-size model for every single task, and how do we kind of support you in finding which model is the best one and even optimizing it from there. I think maybe just a quick plug I'll do is Flash and Flashlight are very, very strong models now for a very low price and very low latency, or much tighter latency than Pro. And I think there's lots of optimizations and things that we can partner on such that you can get very, very high quality for these Flashlights and Flashlight models. Awesome. And then with that, I want to also call out a new program that we have at Google called the Eng-to-Eng. So at Google, because we build the models, we have the team that built the models, and we own the capacity and the chips, we're able to offer support across all these kind of layers, so across quality, speed, and capacity and cost. Maybe just to frame what it is, it's pairing our engineers and our researchers with your engineers and your research teams so that we're able to kind of optimize and create the best performing Gemini model for your use case. Maybe a few things that I'll call out is on the quality side, our engineers have already in the past helped with harness, prompt, or context engineering tips, but also we've done specific serving fixes just for specific customers. So an example is like some of our coding customers would come to us and say like the new Pro model is bad at X, and our engineering and our infra team have actually built like serving fixes and serving patches to address those issues. So that's the kind of like level of partnership that we're able to offer, and we'd love to kind of like, I'd love to highlight that. On the, maybe the capacity side, some of our customers also really care about regional endpoints, or maybe they have lots of like 429 errors, and our engineering teams across capacity and quality are able to kind of provide support such that you're able to use Gemini the way that we want you to and with the way that you want to, and giving you the tools to do that. And then finally, I just had a meeting like yesterday or 2 days ago about a customer talking about streaming and how the number of chunks that they love streaming, but the number of chunks, the minimum number of chunks that need to be outputted before it starts streaming is too high, and how do we get that down? And I have that as an AI to follow up on, and just kind of like maybe the takeaway, and I think it's clear, is out-of-the-box performance is just the starting line. Our engineering team is really here to make sure that it works for you, and the magic of Gemini can really be harnessed. And then with that, I'll move on to like optimizing for Gemini for tomorrow. We'd love to partner with you. We'd love for your input in shaping our roadmap. Again, Gemini is built for our customers, and I've kind of like highlighted 2 of the ways that we've thinking about partnership, but I think there's lots of exploration that we can do. One is around like co-building an eval, especially for these like long horizon or agentic tasks where your harness and your environment really matter a lot, and taking a model and plugging it into that isn't like as easy as kind of like switching out the APIs. We'd love to co-build an eval, and this really helps us kind of like represent your losses and your use cases on our modeling team leaderboards. And the way to maybe kind of like think about this is, imagine like we have a bunch of evals on our modeling leaderboard that every researcher on the Gemini teams look at, and we'd love to create like your customer eval, and every single team could look at this and see like what are the losses, what do they really care about, and is the next model going to do well? For a little bit of context, we probably have like dozens and dozens of new models that are trained every single week, and the one that finally gets to launch isn't necessarily, it's from one of those, and it's kind of too late to really give us feedback at the end when we've already made a decision. This kind of helps you have a voice at that table, have a seat at that table, and say like, this model is good, this model is bad, and we're optimizing for the right thing. And then early access program is a program that we have launched in the last year, where we're allowing our top customers and our top partners to look at, one, what is our roadmap? When's the next model coming? What are the capabilities that you can expect? And then 2 is be able to like play around with, provide feedback, and test on our latest models before we launch them. And that helps kind of customers in 2 ways. One, making sure that we're choosing a model that like performs well on your use cases, and we're factoring that feedback in for future models, but also you're able to kind of shape your roadmaps and make sure you're not doing like any unnecessary engineering work to like move to a new model if we know a new model is coming out, or you're able to kind of like launch the new Gemini models with us on day 1. And yeah, so with that, I'm gonna hand it over to Darvish. He's the Senior Director of Product at Salesforce, and he's going to talk to us about how we've kind of applied both the today and tomorrow model with Salesforce, and we're finding a lot of success for their Agentforce product.
Awesome. Thank you, Daniel. Everybody hear me okay? Excellent. Well, thanks for coming to the session. Hope lunch is settling well for all of you, and on the last day of Next. I'm excited to be here. Thanks to the Google team for inviting me to talk. My name is Darvish. I'm a product manager at Salesforce. And we have an interesting relationship with Google because, of course, we are a Google customer, and they're also a large Salesforce customer. So there's a good synergy there. In fact, Google talked at our event last week in San Francisco about their journey using the Gemini models for the Salesforce Agentforce product. So anyway, the reason I'm here is just to give you a little bit of perspective on what it's like to work really closely with the Google team on the evals and things, and then also just optimizing for thousands of customers right, through our product that will actually consume Gemini within Salesforce use cases. There's a couple programs I lead that are relevant. One is that I'm the lead on integrating Gemini 3, the Gemini 3 models into our prompt builder and our Agentforce products, right? And that's the biggest program for sure that we're embarked on right now related to today. And then secondly, I also am the product manager for our data science team. And the data science team is important because they're doing a lot of the optimization and quality and accuracy testing for Gemini within these products. So that's just a little background. I'm going to try to give you a little bit of context. Now, I know people hate it when speakers do this, but how many folks in the room are AI experts or subject matter experts? Okay, so some of you are bold. How many are developers? I'm just trying to get a feel for like who. A lot of developers. Okay, good. All right, and then how about how about we just proceed? So, Agentforce and Gemini. Agentforce, if you're not familiar with it, it's sort of Salesforce's agentic technology that customers are using to build all kinds of interesting use cases mostly with customer data in our CRM platform. And the reason I have this screenshot up here is because I'm sure you all have your own ways of thinking about like how would we integrate Gemini and the Google platform into your scenarios. For us, because we're both sort of like reselling effectively Gemini, but also we're consuming a massive quantity of Gemini into our platform. There's a lot of complexity there. Also, we're serving a global audience, right? Our customers are in every country in the world. So this slide just basically lays out at a very high level sort of an architecture slide. The way it works, right? We connect to Gemini through Vertex. And we just call that a Salesforce managed instance of Gemini that comes in through our platform, and it runs through this entire layer that we built for doing things like toxicity detection and other protections for customers. And then eventually it gets surfaced within our prompt builder and Agentforce products in the Salesforce platform. We also allow customers to bring their own instance of Gemini if you have your own that maybe you fine-tuned or whatever, and you want to connect that and use that. You can also bring that and use it in this same pipeline. So you can see there's lots of ways that Gemini gets integrated into our platform for many thousands of customers. Just a couple screenshots again for context for those that are not Salesforce customers, just so you understand what I'm talking about in Salesforce, what that actually looks like. So this is our prompt builder product, and I'm not sure how well you can see it, but when a customer goes in, a developer goes in and they want to build something in Salesforce, we basically have the entire Google Gemini family of models available for them to select. We don't distinguish between costs, like it's really up to the customer to pick whatever one they want, and then we're essentially paying for that model, for the tokens for that model from Google. But it gives customers a lot of flexibility, right? So I don't know how many of you would do this internally, but we do like to offer our customers when they're building things as much choice as we reasonably can. And then in Agentforce, so this is a forward-looking slide because this is a feature that we'll launch here probably in May, TBD based on when we finalize things with Google. But today, customers, when they build their agents, there are other model providers in there, but what we're going to open up soon is the ability for a customer to say, I'm a Google customer, I'm a Google partner, whatever, I want to use Google Gemini. And specifically, I'll talk more about this in a second, specifically what happens if a customer selects this option is that all of their agents will default to the Gemini 3 Flash model, right? And we selected Flash based on a lot of evaluation and a lot of work from our data science and our benchmarking teams to decide how much power do we need versus all the other benefits of Flash, which are, have to do with performance and latency. So anyway, this feature is coming soon. And then this is just a screenshot of what we call our audit log. And what it essentially allows customers to do is like, oh, if I have 10,000 Salesforce users and they're all hammering on these agents or these prompts all day long, we allow them to go in and see exactly what models are getting called, what the payload that's sent to the model was. And that allows the customers to do a lot of their own reporting and their own analysis. And that's true whether the customer, you are bringing your own Gemini instance or you're using the one that Salesforce provides. Okay. So when we talk about optimizing for Gemini in Salesforce, there's sort of 4 dimensions that we have to think about, right? And there's more, but at a high level, there's 4. First of all is performance and latency. So our customers will not be happy using Agentforce and other AI products in Salesforce if the performance of Gemini is not doing well. So performance and latency is one of the first things we look at. If this model is being served on Vertex, how is it performing? Is it fast enough? What's the time to first token look like? Et cetera, et cetera. So that's key. The second one I wanted to mention was, of course, cost to serve, which is really more, like I said earlier, that's sort of an internal measure. We're trying to balance between how much provisioning do we do ahead of time for customers globally versus how much do we just sort of pay on demand, right? And there's an interesting balance there, and I'm sure a lot of you as customers will have to wrestle with that as well. The third one is just simply accuracy and quality, right? So this is where our data science team did a lot of work with this long chain of events that happen when you run an agent in Agentforce, right? The system prompt, the user prompt, the protections that we have in place, all these things. We have to make sure that things are behaving as expected. So we did a lot of work for accuracy and quality. And that includes things like, is the agent adhering to the task? How good is Gemini Flash at understanding and actually getting an agentic task to resolution? And what we found is it's actually very, very good, right? So I wanted to say that. And then last but not least, one of the other interesting challenges that we have is that because we have customers in every country, some of those customers, especially in regulated industries, they're very insistent that they know where exactly is that literally the model sitting that's serving my LLM inferences. Where is it? Is it, if I'm in the EU, is it in the EU? Is it, if I'm in Australia, is it in Australia? And so some customers really care about that, and that's something that we have to work through to provide global availability. When we do the benchmarking, whenever a new model comes out from one of the frontier model providers, we do a benchmark and we publish it in our CRM benchmarks on our website. For the Gemini one, we specifically did these 5 target personas, and each of them have their own nuances when we run these benchmark tests. So we do customer service, customer success, field service, marketing, sales development, so on and so forth. And we test both agentic and non-agentic sort of use cases. And I would encourage you to think about one of the things that's been fun to watch evolve is a lot of customers are now doing real agent use cases. But what I've observed is that a lot of times there's a lot of power in a really well-crafted prompt, right? So you sort of we're trying to walk the balance there and give customers guidance on when you really need agent, when you need the power of Gemini. And we're also evaluating against quality, cost, safety, and sustainability, right? So these are all important to us when we look at it. So it's quite a comprehensive process that we go through. Now, when we optimized, one tangible thing that we decided to do, because we are a multiple provider ISV, effectively, right? Customers have the choice if they want to use OpenAI, they want to use Gemini, they want to use Anthropic in our platform. One of the things we decided we needed to do with Gemini, with the data science team, we basically built a per model provider optimization. And what that allows is for our end-to-end, including the system prompt and other things, to really be more tuned specifically to perform well with Gemini. And it's not like you have to do a lot, but there are nuances, obviously, between each of these model providers. And the Google team's been fantastic working really closely with us on this optimization stuff. We're also, our AI research team is collaborating really closely with Google Research to do some work in the future around fine-tuning of models to make them even better. And even eventually what we want to do is allow customers to fine-tune a Gemini model within Salesforce is one of the things we're thinking about. So that's a little bit about what we've done for optimization with Gemini on our platform. I hope that's useful. I'm happy to chat with anybody afterwards, or if we have time, we'll take some questions. I think what I'm going to do now, though, is I'm going to turn it over to Skander, who is going to come up and talk about migration to Gemini 3, and we'll turn it over to him. Thank you.
Thanks, Darvish. Oh, let me kind of flip through some slides here. Yes. So at this point, we're about 3+ years into the Gen AI cycle. And so the question is, if you want to use Gemini 3, a lot of you are probably already using Gemini 2 or some third-party LLM. And so it's not just about using Gemini 3, it's about migrating, so to speak, your existing application to the Gemini 3 API. And the word migrating itself is a little bit sensitive. When we say migrating, you kind of conjure up images of migrating from on-premises to cloud, from a legacy, structured RDBMS something to NoSQL to something like that. And it's not that heavy-handed. It's not that big of a challenge. Now, like, these are still large language models. So it is still an ML model. And the question is, like, can we bring down the process of shifting from one version of Gemini to another to the efficiency and the speed with which we can refresh a predictive model? So with like regular machine learning, it is possible to fully automate the deployment of a new model version. When you retrain a recommendation model or a forecasting model or a customer lifetime value, you automate the retraining, and every time you have new data, you train the model and deploy it to production. It's fully automated. And the question is, like, can we get to that point with large language models? Well, not yet, but we can come pretty close to it. You can think of it as like MLOps++, because you can automate most of the process, but you still have to have like a human review layer because of the power of these models. This is kind of cliche, with great power comes great responsibility. So you need your responsible AI team, your risk and safety teams, your risk and compliance teams, et cetera, to kind of make sure, validate the process. So we can bring it down to the level of automation of a fully automated MLOps process, almost, with that last layer of human verification review. So that's the good news. The bad news is that machine learning and technical debt have a long history together. The whole field of MLOps was essentially triggered by the observation from one of the applied research teams when they surveyed 100+ individual ML teams, and they discovered that there was a lot of technical debt hidden in ML production processes. And there was a landmark paper called ML Machine Learning, the High Interest Credit Card of Technical Debt. And then the anti-patterns that they observed were eventually, were studied, and they eventually drove what became later MLOps. In a sense, like, these are the common anti-patterns that address them. So over the last year and a half or so, our applied AI engineering team has been working with a lot of Google Cloud customers who are already on Palm or on Gemini 1 and helping them upgrade to Gemini 2, and more recently helping them upgrade from Gemini 2 to Gemini 3. And what we've discovered is that large language models are not a high-interest credit card. They are a loan shark. If you have bad prompt engineering practices, if you did not do your prompt tuning and your hill climbing, or as Darvish referred to it, your optimization correctly, you will accrue a huge amount of debt in your prompting templates alone. Even if the rest of your software, deterministic software process is fine, if you did not do your prompting correctly, you will get stuck, and it will be very hard for you to go from one version of a large language model to another. Now, as most of you have observed, the new versions keep coming in quickly. 2.5, 3, 3.1 version, you're often having to deal with a version before it's even GA, and yet you still have to test it because, the GA version is coming out soon. And so, learning how to avoid these anti-patterns is what we are going to kind of go through next. And I'm going to make things even worse. When we go into agents versus prompts, a lot of things become even more complicated, because now establishing the baseline takes more time. Optimizing, you end up finding you have to build the harness before you can even start optimizing your prompts. Building the harness itself becomes like a technical challenge that you need an experienced ML engineer to implement. And then finally, you're no longer thinking about individual prompts. You're now thinking about the entire agent structure, like the tool choices and the trajectory of the agents, et cetera. And so let me kind of formalize the challenge in another way. When you look at, there are two cultures of testing software and managing it in production. For deterministic software, for like traditional software engineering and CI/CD processes, there are some things that are easy and some things that are hard. An example of a thing that's easy for traditional software is that the number of test cases is usually relatively small, and it's something that you can manage and you can decide upfront of very easily. Something that is hard in traditional software testing is that you can't just do unit tests. You have to do unit tests and system tests and end-to-end tests. And for a system test, it's no longer just calling a single API endpoint. It's setting up an environment that kind of looks like it's much closer to like a production environment, just to be able to do the end-to-end test or the system test. For ML engineering, there are other aspects that are challenging and other aspects that are simpler. An aspect of ML engineering that's really simple is that testing an ML model is just a bunch of unit tests. There's no such thing as system test. It's just like, constantly hit the API over and over and over and over with more and more data samples. Right? No, you don't need to really set up an entire environment. You're just like making, the same API call or the same function call over and over and over again. A thing that is very challenging with ML, testing predictive ML systems is that data quality and the statistical significance of your test cases has to be done very rigorously. Like you now have to have in the thousands or sometimes tens of thousands of individual test cases. You need to make sure that they are statistically significant, that they map to the same distribution as the distribution of the data in production, et cetera. So the statistical and kind of like econometric aspect of your test cases is a big challenge. And when you get to like testing agents, you are in the worst of all worlds. Basically, it's as complex as testing traditional software, and you have to have this bring to the table the statistical rigor of like a data science practice or an econometric practice. And what we're noticing is that like most teams are either or, like they're either like traditional software teams and they know their software SDLC lifecycle, their CI/CD, their DevOps really well, but they don't necessarily grasp the statistical challenges that they're going to come up against, or they are ML and data science teams and they know the statistical challenges really well, but they're not used to having to do like full end-to-end DevOps and CI/CD and things like that. And so what we're really witnessing is the need for like more of a cultural change and kind of an integration of two cultures, more so than just like a kind of a tooling change. But the good news is we have started to see what the best practices look like. And the biggest one by far is process. Process. We have worked with some customers where they were one week they were struggling, freaking out to migrate from Gemini 1.5 to Gemini 2.5 or from Gemini 2.5 to 3, and we educated them on the process, and we planned to work with them on the tools, and yet 2 or 3 weeks later, they said, we're good. Now that we know what the process should look like, we're fine. And so what we have here is, the process, the kind of like we have identified the process, and essentially you need to, just like with traditional MLOps, where you isolate the software challenges from the data and from the modeling challenges, same here. You need to make sure that you isolate what are the deterministic software challenges versus what are the data and modeling challenges. So an example of deterministic software is like when we went from Gemini 2 to Gemini 3, the way the thought tokens worked and the way like managing the thinking budget changed. That's a deterministic software challenge that you include as part of your software testing and regression testing process. Kind of more of a data challenge is like, I'll go over the data challenges later, but one example is like, this model kind of tends to like be much more brief in its responses than previous versions of Gemini, right? So this, to kind of like, if you take away one thing from this part of the presentation, it is that process is key, and as long as you follow the process really, and as long as you document and you're systematic in your evals, then going from one version of Gemini to the other is not at all a big deal, and you can get used to doing it systematically and get used to like, being able to upgrade the moment we release a new version of Gemini. So let's look at some of the anti-patterns that you have to avoid in order to make sure that your migration process is seamless. I'm not going to go through all of these. I will focus on a couple of like really kind of important ones that are not so obvious. Like unintentional hill climbing. So what is unintentional hill climbing? It is, or as again, Darvish calls it, optimization. So when you're trying to optimize your prompts for your use case, if you're just like kind of trying things, you know, kind of throwing spaghetti at the wall, like, okay, this didn't work, let's try this other thing. And let's see, oh, I read in this paper that if you tell the model to behave like Captain Picard, suddenly it becomes very good at solving navigation challenges. Right? That's, you know, a combination actually of two anti-patterns, hocus pocus prompting, like magical behavior from the LLM, but also more importantly, you're not really being intentional in how you hill climb. You need to make sure that you're like optimizing your prompts, you're tracking specific loss patterns, you're versioning your prompts, etc. You're tagging multiple metrics and not a single metric. That allows you to be intentional in your hill climbing, and that way the prompts that you optimized are not just optimized, but they're rationalized. And they're much more likely to work well from one model to another versus like, you know, prompts that have been optimized for one version but in a random way so that you don't know that they work with the other one. And then another example that I want to call out, actually they're two closely related examples, is tool ambiguity. So let's say you have a data science agent. You're building a data science agent and you want to enable the users to like automate doing regression models. And you decide to give it the access to sklearn regression models and to stats models regression models and to regression models in R in the name of providing as much choice as possible. That's actually a design anti-pattern because you're confused, you're giving the agent too much autonomy, right? It's linear regression is linear regression. Just choose one regression tool, make sure you know that it's a really good regression tool, test it offline on its own, and then give it one tool. Don't give it too much choice. Don't give it too many different choices of tools, and don't give it like too many, and don't give it ambiguous tools either, right? So that's one example of giving the agent too many design choices and thus like confusing it, and then making it look like it's the model that's not performing well when it's fact like the way you constructed your agentic trajectory is actually confusing. So where are we going from here? Like, again, you know, we were talking about Gemini 3. Last year, my team was doing the exact same thing for Gemini 2. Next year, we're going to be doing it for Gemini 4. What does the long term look like? We need to start thinking about how to architect for resilience and scalability and avoiding technical debt in the long term for these models. And so when you're designing your system, look at the anti-patterns that we just mentioned, make sure you avoid them, focus on the process in order that to like your model is, your application, sorry, is robust against version upgrades. It doesn't like, not every time you migrate to a new version of Gemini, you break everything. So that's number one. Second, incremental changes in factuality. This one is really, really, really important. Let's say that, you know, you're building, I don't know, a hypothetical astronomy agent, right? Whether or not there's going to be an eclipse this year is a incremental change in factuality. Make sure that your model is robust against that. Now, there are going to be non-incremental changes. There are going to be catastrophic changes in factuality. Like a few years back, they decided that Pluto is no longer a planet. Those are unforeseeable events that you're not going to be able to architect against. But that there's an eclipse or not this year is something you need to anticipate up front. And when you're building your guardrails, your grounding sources, choosing your grounding sources, et cetera, make sure that they take into account that some of these facts do change. Now, let me give a more real-world example of this is make sure that when you, for example, build a internal HR knowledge agent that takes into account that small details in HR policy will change from one year to another. We've had, you know, kind of customers who were building such an HR agent and, you know, Gemini is giving us the wrong answer. And then when we looked, it was actually their eval set, which was based on last year's HR policy. Not Gemini was actually giving the correct answer, but their eval set was based on last year's HR policy, not this year's. So make sure that you take into account changes in factuality. And then also make sure that like if you're using like an embedding for your retrieval, that's also a separate model. So you have to be like robust against embedding upgrades. And when you're building an agent that uses a lot of tools, make sure that it's robust against tool version upgrades. You know, back to my data science agent example, if it's using sklearn for regression, as a tool for regression, make sure that it's robust against upgrades in the sklearn API. Or if you're using XGBoost for the regression, make sure that it's, you know, robust against like upgrades to XGBoost. So hopefully, you've kind of gotten a mental model of what the anti-patterns to avoid are and what the best practices. And again, I can't emphasize enough, process is king. If you follow the process, you're 90% of the way there. With that, I'll hand it back to Daniel to tell us how you can partner with us.
Thank you, thank you. Awesome, awesome. All right, I'll just close this out, and I think we may have a few minutes for questions if there's any, but the thing that I kind of want to drill home is the next time you come across something that makes you feel like, hey, this is not working, I cannot use Gemini for XYZ reason, whether it's like terms of conditions, regional endpoints, the model quality not being there, whatever, I'd encourage you to feel empowered, to feel like you can reach out to us, ask us for help, and ask us to fix this, because we're happy to do it. And I'll just flash some things up. So we have a form here for early access. If you want to fill out this form, this helps us kind of like gauge who you are and if you're interested in getting early access as well as co-building an eval. And then I've just added like reach out to your Google rep. Feel free to reach out to whoever you know, Google, me, or your account team, and we're happy to kind of figure out how we can build a partnership.